This is Arian Solids preview video 8.5. We'll get to this yet. 8.5, the re-record, 8.5, volume of prisms and cylinders. Let's take a moment and breathe. Where's the music? So sorry, no music. Needless to say, take a moment. Exhale. There's music in your head, I'm sure there is. Okay, friends, you are right here in your preview notes, prisms and cylinders. Couple reasons why I'm super excited about this particular is that we are finally graduating. We've been in 2 dimensions all year. 1 dimension is length. 2 dimensions is length and width, like a piece of paper. We are finally getting into 3-dimensional, got my hands on stuff, solids. So we're dealing with prisms and cylinders today. Now, one of the main skills you're going to be learning is drawing prisms and cylinders. And there's a reason why prisms and cylinders are in the same, what are called solids families. Solids are these things. You learned them in kindergarten. Rectangular prism, a cylinder, a can, a pyramid, a sphere is a solid. So a prism and a cylinder have these 2 qualities. They have 2 bases, and they're connected by rectangular faces. 2 bases connected by rectangular faces. Ready? I'm going to start with a rectangular prism. So there is one of your bases. We're just going to trace it and drop it straight down. The goal is to get all your edges parallel to each other. So this parallel to that, this parallel to that. Now you have something that looks 3D, but to represent depth, these edges in the back are not visible if this was actually a complete solid. So we dot the edges or dash the edges that are not visible. That is a rectangular prism. Rectangular prism. And we're just going to keep going here. There's one base. And then I'm going to draw, and this is another way to draw, is to draw a parallel base. I know those edges in the back are not visible. And connect the corners. Triangular prism. Here's one base. This is a regular pentagonal prism. I'm going to float another base, trying to make all my edges parallel. These 2 edges are not parallel. And connect. And then a cylinder here. We just trace this, draw another floating, dotted towards the back, bring it down. All right. So definition of a prism is it has 2 bases. So these would be the bases. Bases, 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 bases. Those are your bases. And they're connected by rectangular faces. Now for a cylinder, you're like, there's no rectangle for a cylinder. But there is. Watch carefully. Instead of multiple rectangles, a cylinder has 2 bases, and it has one long rectangular face, if you will, that connects the 2 bases. That would be like the label on this can. So even in a cylinder, the bases are connected by a rectangle. Two bases connected by rectangles. Pyramids and cones are in the same family, if you will, family grouping, meaning they have similar characteristics. They only have one base, and that's connected by triangles. So those are all called vertexes. Now we just connect the corners. And the back edges is dotted again because you can't see it. Technically, these edges should be dotted as well. Go ahead and put dots there. That would be solid and solid. That is a square-based prism, pyramid. Right here, we connect the corners. Dotted in the back, dotted edge, solid. That is a triangular pyramid. That is a square-based pyramid, a triangular pyramid. Connect the corners. This back edge is dotted, solid, solid, solid. This should be dashed as well, and this should be dashed. That is a pentagonal-based pyramid. And of course, we have the cone. Solid in the front, dashed in the back. Okay, for this lesson, this particular lesson, we are going to only talk about the prism and cylinder family. So we're focused on that family. The next video will be the other one. The most important skill when you're dealing with prisms is identifying the bases, because all the equations that you're going to use are going to have a capital B, and that capital B is area of the base. Notice I'm using a capital B, not a lowercase b. That's because it's a two-dimensional area. So identifying what those bases are is super important. So how do you find the bases? You find the bases through CPR. The bases are congruent, they are parallel, and the bases are connected by rectangles. Rectangles dash connected. The bases, there's two of them. They're congruent, they're parallel, and they're rectangularly connected. CPR. Let me show you what I mean by that, because you have to be able to spot the bases. So let's start with the cylinder. In the cylinder, these are the two bases, the top and the bottom, if you will. In fact, I'm using improper terminology. I'm using top and bottom, and there is no top and bottom. They are right here, the circles, and they are connected by a rectangle. We already established that. So in a cylinder, those are the bases. So here is a hexagonal prism, and the hexagonal prism, these are the bases. And so even if I turn it sideways, they're still the bases. And then they're connected by rectangles. All of these are rectangles. Then you got something really weird looking like this, and you're like, where are the bases in this physical object? If I go like this, okay, they are parallel, CPR, they are parallel, but they're not congruent. That is not congruent to this, okay? And if I hold it like this, they're parallel, but again, they're not congruent. The bases have to be three things: congruent, parallel, and nothing but rectangles connecting them. So in this object, these two L's are the bases. Why are the L's the bases? One, they're congruent in shape. Two, they're parallel. And three, everything that connects them, see where my thumb is some form of a rectangle. Congruent, parallel, connected by a rectangle. So on that note, take a look here at this prism here. Your base would not be bottom. That's not the base. Don't shade it. Your bases would be these two triangles. Those would be your bases. Why? One, they are congruent. Two, they're parallel to each other. Three, everything that connects them, this down here, and this in the back, everything that connects those two yellow triangles is connected by a rectangle. Congruent, parallel, connected by a rectangle. Go right down here as fast as you can. I want you to try to shade what you believe the bases are. I'll give you 20 seconds. Okay, and then we will go over them super quick. 20 seconds. Identify the bases. So let's take a look up here. This is what you should have shaded. I'm going to do this very quick. In yellow, I'm going to shade. In every case, these are the bases. They are congruent, they are parallel, and they're connected by rectangles. Congruent and parallel and congruent by rectangles. Congruent and parallel, connected by rectangles. Congruent and parallel, connected by rectangles. These are the bases. Super important. You're able to identify them. Okay, so in the equations that we learn, all of these, we're going to be using a capital B, and capital B means area of. Okay, now that you can, find the bases. We're going to show you here the equation for the volume of a base. And volume is the amount of stuff inside a solid. So in all these equations, the word base stands for the area of the base. And I'm going to be very specific. We use a capital B for that. A capital B means area of the base. Super important you understand that. Let's see, what color do I want to make that? I'm going to make that green. So capital B is going to mean area of the base. What are the three qualities of the bases? They're congruent shapes. There's two of them, only two. They are parallel, and they're connected by rectangles. So to get the volume of any prism, it's going to be this very simple equation. So there's a triangular prism here. And what we do is we find in a volume of a prism, you find the area of the base. And then the only thing that changes, imagine liquid filling this, is that the only thing that changes is the height. So you start by finding the area of the base times the height. And height is distance between the bases. That's a super important concept. So here, height does not mean up and down. In this can, if this can was turned sideways, the distance between the bases would be the distance between your fingertips. So the height would be horizontal. Here, in this, those two hexagons are the bases, and whether I hold it sideways or up, it's the distance between the bases would be the height. So right here, we're going to identify our bases. And we are going to find the area of one base. I'm going to shade them both, but we're only going to find the area of one base. So keep that in mind. These would be the bases. B, right here. Here would be your bases. Right here, and here would be your bases here. Right here. So all of these are the bases. But this capital B, it defines something different depending on the base. So here, if I wanted to find the area of this base, it would be this, perimeter times apothem over 2, because it's a regular polygon. Here, if I wanted to find the area of this base, watch very carefully, we would average these parallel lines, which we're going to call base 1, base 2. Notice I have lowercase b's. That's because they're one dimension, they're only length. So for this trapezoid, we would average the bases times the height of the trapezoid. All of this is showing you that the B can change depending on the trapezoid. Here, if it's a square or a rectangle, your base is simply length times width. Here, your base is a circle, so it's pi r squared. And here, your base is a right triangle, so it's leg times leg over 2. So on the next page, when you see a capital B, the capital B could be any one of these equations because the base changes with the shape. Remember, height is the distance between the bases. So this soup can, you guys are used to seeing height vertically, so if your bases are the two circles, then the height would be this way also, the distance between the circles. Okay, so height, H-E-I-G-H-T, is always the distance between the bases. So taking a look here, how do you find volume? It's really simple. You find the area of the base, and you times by the height, because the height is what changes. So we find the area of the base, and we simply times by the height. So if I wanted to find the volume of this, I find the area of the base times the height. We're going to walk through some problems together here. Step number 1 is to always identify shade, base, equations. Circle, plug, chug. Shade, base, equations. Circle, plug, chug. Shade the bases. That's the first step. Those are our bases because of CPR. They are congruent, they're parallel, and then there's nothing but a rectangle connecting them. Congruent, parallel, connected by rectangles. So step number 1, I shade my base. 2. I find the area of my base. My base is a right triangle. So my area is going to be leg times leg over 2. Leg times leg over 2, because it's a right triangle. I pull that information from this page here. So our leg here, trace it, circle, plug, chug, 7. Trace it, circle, plug, chug, 24 over 2. Try to resist the temptation to use a calculator here, friends, if you can resist that temptation. So I find that it's 84, and I don't have units here, so I'm just going to write units squared. Box that, put a giant capital B. That is your capital B base. The volume equation is base times the height. We already have our base. You just found it. Your base is the area of one of these triangles, and you already have that. You just found it, so we're just going to pop it in right there. 84. Height is the distance between the bases. So the most common mistake here students make is they assume vertical means height. That is not the height there. Your height is going to be any one of these edges, because any one of these edges is the distance between the bases. Height is not a vertical concept. It's a distance between the bases concept. So if you trace that, we get our height is going to be 28. Yeah, absolutely. 28. Base times height. 67.
So I got the answer.
Great. Is that a 6? Yes, yes, yes. 7. Is that it?
Yeah. No,
Okay.
no. It's supposed to be 300.
Is there a 3 there?
Yeah, look, 6 plus 6 equals 12. You have to add the 1.
Add the 1, right? But there wasn't anything there.
Yeah, there is. Look, it's
Okay.
Look, do that again.
Okay, that's 2. Carry the 3. 8 times 8, so that's 67. 67. 0. 2 times that, that's 8. That's 16.
Look,
Yes.
watch.
Great.
That's 15.
2. 15. Carry the 1. Yeah.
That's
yeah.
3.
Okay,
It's a 2.
does 12. That's 13. Carry the 1. Yep. 2. Yeah.
No, that's the answer.
I had it.
No, you put 7.
Did I put 7
You
there?
put 7 right there.
You're right, I did. I stand corrected. That's by E.K. Clinton there, ladies and gentlemen. Nice job, E.K. On that note, and it's going to be units cubed now, friends, because volume is 3 dimensions. Let's do another one. Shade base equations. Circle, plug, chug. Step number 1 is you want to shade your bases. The bases are congruent, parallel, connected by a rectangle. There's your base here. So our base here is a circle. So our B now is pi r squared. So the B can change. That's super important. Base times height, this B here changes depending on the shape. That's important. That's why you need to have all these area equations from the previous page memorized. All of these must be memorized. So we come down here, and our base is pi r squared. Our radius is 4. So we're going to do 4 squared times pi. 4 squared, 16 pi. Box that. That's your base. We're going to leave this in pi form. We don't have to do anything else with it. It's easier. So our base is 16 pi. Our height, the distance between the bases, which is 12.
It's theta over 360 times.
Do this longhand, it's good for you. 12, carry the 1. That's 3, 0, 6, 1. So we get here, our volume is 192 pi units cubed. Let's see, were there any units provided? Nope. That is your volume. Base times height. Base times height. These 2 pages, you're going to try on your own, pause the video, and restart. All right, welcome back. Hopefully you actually stopped.
Wait, Miss Wade. I didn't even get that, Miss Wade.
Step number 1, you were supposed to shade your bases. So shade your bases, and your base is a circle here. Pi r squared. Super important. Always trace your radius, because if you use 22 there, you would be wrong. It's 11. Always trace. So we're going to do 11 squared times pi. 121 pi. And that's your base. And it's inches squared. Again, we're leaving it in pi form because there's nothing else we need to do with it. Now, if this was a can and we needed to fill it up, okay, like we needed to know the volume of this tuna can, it's going to be base times the height, which is the distance between the bases. So our height here is right here, that 10. Base times height. Our base, 121 pi. Our height, 10. Just add the 0. Volume equals 1,210 pi inches cubed. That would be the volume there. And you can translate it to an approximation form if you need to do something else with it. This one, your bases, capital B bases, would be this and this, because they are congruent, they are parallel, they're connected by nothing but rectangles. So your capital B here is a trapezoid. Trapezoids are a little confusing because you're going to hear the word base multiple times. To find the area of that trapezoid, you average the one-dimensional bases. So we're using lowercase b's. Base 1, base 2 over 2. Average those bases, lowercase, times the height, which is the distance between the bases. All of this is the area of that trapezoid, which is the base, capital B, of the solid. So we're going to do that. One base is 18, plus the other base is 15 over 2 times your height. I know you're grabbing a calculator for this one because you already know it's a decimal. So we'll take our short bit there. There's our average of the bases times the height. So we get our capital B is 165 units squared. If we were to have a volume, if I were to make that out of, let's say, solid gold, and I want to know what the volume is, would be base times the height. Now that height is different from this height. That is the height of the trapezoid. This is the height of the prism. The height of the prism is this distance between the bases. So my base we already got is 165. The height, distance between the bases, is 24.
Get it back in the left. Yeah, so we can get it back and forth.
And we get 3,960. And check for units, no units, but that's going to be units cubed because it's volume, and volume is 3 dimensions.
This way. Can I tell your view or something?
This last one I'm going to do with you, it is called a composite solid. So it is made up of 2 different solids, if you will. We have a rectangular prism here, and we have a triangular prism there. But we're going to treat this as one single prism. So our bases are going to be this pentagon, 1, 2, 3, 4, 5. And then your other base is going to be on the other side that you can't see. So this is going to be your capital B. Your height is the distance between the bases. So if we wanted the entire air volume of this barn, let's say this was a warehouse, you have to figure out what is the maximum volume. You're the fire marshal, you need to know how many sprinklers per volume. So you have to find the volume of this barn-like structure. We're gonna do base times height here. And your base is these 2 together. So we're going to do that separately. So this base has a composite. It's made up of 2 things. One, a rectangle, which is length times width, 42 times 20. That's our rectangle. 2, a triangle. And our triangle here is base, 42, times that height, which if you notice the hatch marks, is also 20, but it's over 2. And we're adding those together because it's a composite shape. So 10 times 42 is 420. That's going to be 840 plus 420. So 1,260 units squared is going to be your capital B here. And then base times height, we simply times by the height, which is the distance between the bases, which is 70.
Who said that?
0, 2, carry the 4, 14, 18, carry the 1, and 8. And we have here 0, 0, 2, 8, 8. I know some of you, without doing that on a calculator, is making you nervous, so we're doing the calculator as well. 840 times 420. Oh, we've got the 840. Hang on.
Bro, bad baby, bro.
840 times 420. There it is. Oh, hang on. No, we're not doing that one. We are doing base times height. Our base is 1260 times our height, which is 70. That was something different. There it is, 88,200. That is your volume. Summarize, friends, what you learned from today's lesson.